Hey guys, so we're going to work on an area lesson that's a little bit different than what we've been doing. We're going to use our knowledge of finding the area of rectangles to solve these problems, but they don't start out as rectangles, so we're going to have to break them apart or make composite shapes from make rectangles from the composite shapes. So here we have a garden. It says shrubs, trees, flowers, and plants can be bought at Mr. Corley's nursery. What is the area of the nursery's garden at the right? Break the composite figure into two smaller parts. I'm just going to draw a line right here to break it apart into this rectangle and this rectangle. Remember, to find area, we need to have a length and a width for each rectangle. So since this has a length and a width and a length and a width, I can do this. So now we have it broken apart into our two rectangles. Rectangle 1 has a length of 10 and a width of 8, and rectangle 2 has a length of 12 and a width of 8. So 10 times 8 equals 80. And 12 times 8, they've broken apart into 10 times 8 to make it a little easier. 80 and 2 times 8, because 12 can be broken apart into 10 and 2. 16. And then 80 plus 16 is 96. So the area of rectangle 1 is 80 square yards, and the area of rectangle 2 is 96 square yards. So now we have to put that back together to find the area of the whole garden. And 80 plus 96 is 176. The area of the composite figure is 176 square yards. In example 2, we're finding the area of a composite figure, and they've already broken the figure into smaller parts to find 3 rectangles. We've got 2 rectangles that are of the same size, rectangle 2 and 3, and a rectangle that is longer and skinnier than rectangle 2 and 3, which is rectangle 1. So it can be broken apart into 3 rectangles. Now we're going to find the area of each rectangle, and then add those numbers back together to find the total area. So length of 12 and width of 2 in rectangle 1, so 12 times 2. They've broken apart. 10 times 2 is 20, and 2 times 2 is 4, 24. We could have done 12 times 2 in our head, I think, but they wanted to show us one way to decompose it. And the length and width of rectangle 2 and 3 is 24 square meters. So remember, we have 2 rectangles that are 24 square meters there. So we have 1, 2, 3 rectangles, and they all have an area of 24 square meters. So 24 plus 24 plus 24 is 4, 8, 12, 2, 4, 6, 7. 72 square meters. Now I'm going to practice. Find the area of this composite figure. So I can either break this apart here or here. I'm going to choose the second way because I just think that this will be a little bit easier, but either way will work. So we have a length of 7 and a width of 3 in this top rectangle, and we don't know the width of the bottom rectangle, so we have to do a little math here. If this length is 5 and this is 3, and we want to know what this little side is, we can take 5 minus 3, and that will tell us that this is only 2 centimeters long. Okay? Now we're no longer working with 5. We have 2 and 4, 7 and 3. So 7 times 3 and 4 times 2. 7 times 3 is 21. 4 times 2 is 8. So we have a total area of 29 square centimeters. Now finding the area of these composite figures. Breaking it apart into two rectangles, I'm going to go right here because it already has a length and a width, and a length and a width given to us. I don't have to do any extra work here. So 10 times 4 and 9 times 8. 10 times 4 is 40, 9 times 8 is 72. Add those together, 2 and 11, and we have 112 square feet. Okay, again over here I'm going to divide it the easiest way so that I don't have to do any extra work. They've already given me a length and a width for the top rectangle and a length and a width for the bottom rectangle. So 5 times 3 and 10 times 2. 5 times 3 is 15 and 10 times 2 is 20. So 15 plus 20 is 35. The area is 35 square meters. Alright, on this one I'm going to show you two different ways that you could solve this problem and get the same answer. So we could break it right here so that we have this little rectangle and this big rectangle. Okay, it's going to be 6 and 3 for this rectangle, 6 times 3. And then we have to figure out what this little rectangle is. To find that, we're going to take 9 minus 6, because that will tell us this side, and that's 3. And then 3 minus 2 to tell us this side, and that's 1. So 6 times 3 equals 18, and 1 times 3 equals 3, for a total area of 21 square feet. Now let me show you the other way. Alright, if I break it this way, oh hold on, I don't want a highlighter, I wanted a pen. Okay, if I break it this way, we have 6 and 2, okay, for this rectangle. And to find this little short side, we're going to do 3 minus 2, and that's 1. And then the length is 9, so 9 times 1. And just solve for your products, 12 and 9. 12 plus 9 is 21 as well. So you can break it either way. It's just whichever is easiest for you to find the length and width in your brain. Some of us are going to see one way is easier than the other. So the answer is 21 square feet. And let's move on to the next composite figure. I want to split it this way because it says that this is 11 and this is 2. And this is 9 and this is 4. So I can find both of the rectangles without doing any addition or subtraction. So 11 times 2 and 9 times 4. 11 times 2 is 22, and 9 times 4 is 36. When we add those two rectangle areas together, we have 8 and 5, so 58 yards squared. Alright, number 7 says, what is the area of the top of the desk? So as you can see, the desk has 3 different rectangles that we're going to have to work with, and I'm going to split it this way. Okay, that tells me that this side is 6, and this side we're going to have to solve for. We know that the whole side over here is 3, and this inside edge is 1, so 3 minus 1 is 2. Erase and make that a little neater so I can read it. This side is 2. We're going to get rid of our 3. Alright, and then these little rectangles, we have 1 by 2 and 1 by 2. Okay, so we're just solving for that top part, the part that's the light tan shade. Okay, this, and this. Okay, so 6 times 2, 2 times 1, and 2 times 1. 6 times 2 is 12, 2 times 1 is 2, and 2 times 1 is 2. Add those 3 rectangle areas together, 2, 4, 6, and 1. So the total area of the top of the desk is 16 square feet. All right, now we're working with a miniature golf course. Courtney is playing miniature golf. What is the area of the composite figure? I'm going to break it here and I think here. Okay, so we have this rectangle is 4 and 2, so 4 times 2. This rectangle is 4, and we don't know this length yet, so we have to look at this. We have 3 and 1. So 3 minus 1 is 2. Okay, so we're going to get rid of that, and that's 2 feet now. And then 2 and 1. So 4 times 2, 4 times 2, and 2 times 1. So we have 8, 8, and 2. 8 plus 8 is 16, 17, 18. So 18 square feet is the area of the golf course. And then it says, explain how you could find the area a different way. Would the area of the figure change? So just like we did earlier, we are going to now change it up, divide it into rectangles differently, and see if we get the same answer. All right, so let's go this way and this way. So this rectangle right here is 2, and this is where it gets a little more tricky. To find the other side length, we're going to have to do a little extra math. So this whole thing is 4, and this is 3, but this part is not counted in our 4. Okay, so first we have to figure out that 3 minus 1 is 2, and then, so that would mean this part is 2, and 4 minus 2 is 2. So this is going to be 2 feet. Okay. All right, then we have this rectangle right here that we need to find our measurements for, and this rectangle right here. All right, so we know that this is left with 2, and this length right here needs to be found. So 4 plus 2 is 6, and 6 minus 2 is 4, so this is actually 4 feet. And then over here, it's already given us the lengths 3 and 2. So we have 4 times 2, 2 times 2, and 3 times 2. 4 times 2 is 8, 2 times 2 is 4, and 3 times 2 is 6. Add those together. 6 plus 4 is 10, and 10 plus 8 is 18. So, would the area of the figure change? No. The area does not change. We just split the figure differently. The area inside is still the same. And our last question asked us to draw and label 2 composite figures that have the same area but different perimeters. This is going to take a little extra thinking here. Alright, I've drawn some figures here, and I decided I wanted them both to have an area of 24 square units. So let's check that I've done that correctly. 6 times 2 and 4 times 3. And then 5 times 2 and 7 times 2. 6 times 2 is 12. 4 times 3 is 12. 12 plus 12 is 24. 5 times 2 is 10. 7 times 2 is 14. 4 and 2, 24. So they both have the same area, which is what it requires, but they need to have different perimeters. To find the perimeter, we have to add up all of the side lengths. So I'm going to go ahead and label all of the side lengths, and then we'll add those together. So over here, this side is going to be 4 because it's the same length as this side in a rectangle. And then this side and this side are the same length. And then 6 minus 3 is 3. So now I think we have all those sides labeled. And then 2 and 2 add up to be 4 for this whole side length. And 7 minus 5 is 2 for this side length. And now we have all of those labeled. So now we need to find the perimeter. I'm going to change colors so we can kind of see what we're working with here. All right, 6 plus 2 plus 2 plus 3 plus 4 plus 3 plus 4 will give us the perimeter of that. So let's add that up. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This one has a perimeter of 24 units. Now we need to add these up. 5, 2, 2, 2, 7, and 4. All right. 5 plus 2, 5, 6, 7, 8, 9, 10, 11. 11 plus 7 is 18, 19, 20, 21, 22. So they are close, but this figure has 2 less units in perimeter than this figure. Very interesting. That takes a little extra thinking. That's why it's a brain builder. It requires lots of different steps. You won't probably see any of those on your homework today, but maybe in the next couple of weeks when we come back to this and continue to work on it. I hope you guys have a great day. Bye.